Hi everyone, Mateus de here, and I'm going to be showing you a little bit of dcrd's architecture, and I'm going to try and show you how the dcrd blockchain, how the peers, how all the full nodes figure out who are the winners who are the winning tickets in the blockchain lottery that happens every block. So on dcrd, at every block, 5 tickets from the live ticket pool are chosen to vote on the validity of the previous block. And there was a question on Slack and Reddit about how the winners are found, how are they determined, how the tickets that win this lottery are determined. Jrick and Dave have provided the exact point in the code where that choice is made or where that choice is found, but I'm going to try and show you in an alternative way how you could figure out that answer without going directly to the file. So this is a video mostly for someone that is looking to understand a little bit of the architecture of dcrd's blockchain and how you could start figuring out how things are organized to answer your own questions about how dcrd processes things. And if you want to start hacking on dcrd's code base, what you need to do to understand it, or not understand it completely, but to start to have a mental model of how dcrd's code base is organized. So the question is how to figure out how the full nodes figure out who are the winning tickets. So we're going to start in general on a blockchain project. You can start figuring things out from a specific point. So this is dcrd, and there are a lot of packages on the code base, but unsurprisingly there's one named blockchain which is a good starting point if you want to try to understand how the blockchain works. And if you just look at, there are a lot of sub packages, there are a lot of files here, but one good idea, one place that you can start looking for things if you want to know how dcrd blockchain works is you can start by how the full nodes validate a candidate block, a potential block to be connected to the blockchain. So there's a file here very helpfully named validate.go. Going to open it up here, and this file here, as you might guess, is a file related to validation functions of the blockchain. So there are a lot of stuff. This is a reasonably big file, has over 2,700 lines of code, so it's a little bit unwieldy to just jump in. Let's take a look here of what it's got. So it has, let's say at the exported functions mainly, block locator, calc work, check block sanity. So a lot of stuff, deserialize, encode flags. Here is Coinbase TX. Okay, so a lot of stuff here on this file. Use logger upgrade or database upgrade code is here. Okay, vote bits approved parents. So a lot of stuff here that you can start looking. Usually in the case of validate, there are a lot of check functions. So check proof of work ensures the block header bits indicate the target difficulty is min max. So this thing here is what is figuring out if the candidate block has the correct amount of proof of work, check proof of stake, another cool thing to dig in later on. Okay, calc stake volt subsidy based on high. Okay, calculates. Okay, cool. Okay, so let's see types here. There's a blockchain type here in this file, which is very helpful. I'm going to start looking at it. Let me increase here a little bit. Blockchain provides functions for working with the dcrd blockchain, which is really what we want. And okay, so let's look at the functions here. Block high, calc next, required stake difficulty v1 and v2. Okay, so this is interesting. This is related to the on-chain voting that passed last year regarding the algorithm for ticket price, DCP1. This is cool to look at if you want to know the difference between the algorithms. Calc stake version. Okay, check allowed. Oh, check allowed revocations, check allowed votes. So this is an interesting point to start looking for how dcrd determines the winners of tickets. So check allowed votes, perform validations, now votes in the block to ensure they spend tickets that are actually allowed to vote per the lottery. So this function here is trying to figure out whether the votes in a given block are the ones that are allowed. So this is the interesting thing when you're trying to figure out how the blockchain does something specific. Starting at the validation functions is useful because you can, if a block is allowed to be inserted into the blockchain or to be connected to the blockchain, that means that is a valid block. If a block does not pass validation and is not allowed to be connected to the blockchain, this means that the block does not follow the consensus rules. So this means that that block is trying to perform a double spend, or it has some transaction that is not allowed by the consensus rules. So validations, the validation functions in general, help you to get a sense of what is allowed in the blockchain or not. So everything that is allowed by these functions is allowed by consensus rules. So check allowed votes, performance validations to ensure they spend tickets that are allowed to vote per the lottery. So let's take a quick look at this function here. Determine the winning ticket hashes. Okay, parent stake node dot winners. This is a good try to see, to dig deeper. Okay, if not, yes, SSGen. Block contains vote for ineligible tickets. So if some transaction, some stake transaction, some vote staking transaction, because this is skipping the loop in case of not votes. So if a vote is not found on the list of winning tickets for the parent stake node, then this block has an error and is not going to be allowed by consensus rules. So we need to figure out what exactly is coming from these winners right here. So parent stake node is the node for the parent block of the blockchain. So this is trying to validate. Let's see where this check allowed votes is called. It's called here. What function is this? Check block context, performs several validation checks on the block which depend on its position within the blockchain. So this function here, check block connect, is calling the function check allowed votes if the block high is higher than stake validation high. So stake validation high is the high on mainnet or testnet or whatever net where votes need to be cast. So it's checking the allowed, if the votes are allowed. If they are not, this check fails. And if they are allowed, meaning the votes are the winning votes of the lottery, then this block is going to be allowed. So the only votes allowed in a future block are the ones that have been selected by the lottery. So let's check here. Check allowed votes. This is calling parent stake node dot winners, or this is, where is this coming from? We're in a different file now, tickets.go, on the blockchain stake package, which is kind of makes sense, right? Because we're trying to figure out the voters of the stake. There's an interesting file here, lottery. We might want to take a look at it in a bit, but this winners function here returns the list of owners. It's just returning a member of this structure here next to winners. There seems to be a lot of places where it's used. Let's see. Okay, let's hit here, see where it's using Genesis node. Okay, not really useful to know. Genesis node, so this is his init database state. Okay, so this is probably called at startup time, not really useful. Restore the next winners for the node. Next winners for the node. This is just loading some stuff from state. This is being called on load best node. Is used when the blockchain is initialized, so not really useful right now. Okay, let's keep looking. Connect node. Okay, connect node. Connects a child to a parent stake node, returning the modified stake node for the child. Okay, so let's see here. This might be more interesting. Iterate through all possible winners, construct the undo data. Okay, blah blah blah. Database auto update to expire, find expiring tickets and drop them as well. Okay, so this function here, connect node, is trying to, oh look here, lottery IV. So this is interesting. Connect node is probably doing something related to the blockchain. To the stake portion of the blockchain. Node here is pointer to a stake node, which has high, live tickets, missed tickets, revoked tickets. Okay, so this is thing here is connecting a node to the online or live or probably in memory structure of the blockchain. Okay, so let's see what else. So this part here is dealing with expired tickets. Okay, cool. This part here is trying to work with the revoked tickets, process our revocations. Okay, add all new tickets. Okay, so this is working with the new tickets. First block voted, begin calculating winners at the block before state validation high. Okay, so this thing here is probably the thing we're looking for. Okay, connected high, connected node dot high, higher than stake validation high. It's initializing the PRNG from the lottery IV. It's finding the tickets indexes and fetch winners. Okay, so this thing here is probably the most interesting thing we're looking for. New SHA-256 PRNG. Oh, can be used to calc. Total produce the same if they are called at the same seeds. Okay, so This thing here is initializing the PRNG, okay, and then calling this function here, find ticket indexes, given the lane of live tickets. So live tickets is our live ticket pool. Given how many tickets per block are allowed, and the PRNG. So let's look at this function here. Find tickets, find n-man unique index numbers from a list length size. So it's getting here the list, figuring out, it's calling this PRNG here, looking for a number of tickets and returning a slice of ints which are indexes into the ticket pool for the winners. So let's just double check here. This parameter here, tickets per block, it's from params. What's params? Star params. So let's see if we can figure out. Okay, tickets per block, average number of tickets per block. Okay. Okay, so find tickets, find ticket indexes, size n and PRNG. Okay, cool. So this thing here is the function that is actually repeatedly calling the PRNG to figure out the indexes of the tickets, the winning tickets. So basically you have a ticket pool. So we're going to have tickets A, B, E, 3, F, E, blah, 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 B, F, 3, D, F, E, blah, 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 and so on. You're going to have, so this is the live ticket pool at a given block high. You're going to have that PRNG selecting, let's see, this one, and this one, and it's going to select a number of tickets here. It's going to return this here, then this fetch winners is getting past the indexes and the list of live tickets. So, and then you're going to get the next winner's key, which probably has the hash. So you can see here it's casting it into a hash. So basically this is the thing that is figuring out the tickets given the PRNG and given the lottery IV. So now the question is, where is lottery IV coming from? So we know that, so just to recap, this is the function connect block, which is on the blockchain stake package. So this is connecting a new stake node, so a node in the in-memory representation of the blockchain, and it's figuring out the winners based on this PRNG initialized by this lottery IV, and then it's picking up, and from here, after figuring out the indexes of the tickets, it will fetch the actual tickets here. Okay, cool. So let's see where lottery IV comes from. Let's see if we can figure it out. This comes from connect node, which comes from this here. Okay, no more calls here, so there's probably some other call somewhere. Let's try to figure out what calls connect node. Oh, okay, a lot of stuff calls connect node. These are tests. Okay, tickets.go, which is where we are. Stake node blockchain n.lottery IV, which functions this one. Fetch stake node. Okay. Comes from n. What is n here? It's a block node dot lottery IV. Okay, so this is promising. Let's see what a block node dot lottery IV returns. Lottery IV returns the initial for the deterministic. This function is safe. Okay. Serialize the block header. Okay. Okay, so this function here of the block node structure returns the lottery IV. It returns by calling this function concatenated PRNG IV given the block header. Okay, so we have just to recap, we're figuring out where lottery IV comes from. It comes from this function given the header of a block node. So we have a block. We have the header and the transactions of the block. So the PRNG IV comes from the header of the block. Okay, so let's try to see what does this function do. Calc hash something. Calculates and returns the initialization vector for a given seed. Okay, where am I here? I'm still at the, okay, so I'm at the lottery.go file. This here gets this seed, which we know is the block header. And then it basically just hashing the header. This can be used with new blah 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 to arrive the same values when calling new hash with this seed. Okay, so basically this is calling calc. So the lottery IV for a given block node is called from the hash of the block header. Okay, header dot serialize buff. So header is the block header. Serialize is obviously serializing the header into a buffer, and then we calculate the hash, the chain hash. Chain hash is the Blake, if I'm not mistaken. Oh, there you go. It's the Blake 256. Okay, it's the Blake 256 of the block header. So let's backtrack here. The lottery IV is the Blake 256 of the block header. Okay, and then the winning, where was I? The tickets, there you go. Okay, here we are. And then the PRNG is this guy here. And then the tickets are found by calling this function here. Okay, so this is how basically the dcrd nodes figure out who or which tickets are winning the blockchain lottery by picking the block header of the parent block from the new one. Remember that a ticket votes on the validity of the previous block, so this here is going to be the header of the previous block. It's going to calculate the lottery IV. This is going to initialize a PRNG, and this PRNG is going to be used to find the winning tickets given the live ticket pool. This here is the live ticket pool. Okay, so this is basically how dcrd figures out. So hopefully this video has given you a little bit of an insight on how dcrd works. As I mentioned, all of these places that we found were given by Jrick on Slack and by Dave on previous sensors, but we've been able to reach or to find these particular functions by starting at the validation functions for the blockchain. So this is a good place to start if you have questions about how does dcrd hold. So for example, how does dcrd check the proof of stake or proof of work? If you want to figure out the specific algorithm, the actual algorithm that is used to increase the ticket price or to change the ticket price based on how many tickets are added to the ticket pool at each block. So you can start looking at the validation functions, which is an interesting entry point to get a sense of how dcrd works. Okay, hopefully this has been useful for people that are starting out in blockchain programming and specifically in dcrd. Okay, thank you very much. See you next time.